Now let us discuss about the register relative addressing. Register relative addressing is similar to base plus index addressing. So far we have discussed in the previous class. Here the data in a segment of memory are addressed by adding the displacement to the contents of a base or index registers. What I mean by that, the data in a segment of memory are addressed by adding the displacement to the contents of the base or a index register. Let us take an example here. Move cx comma bx plus 0010h. So here the base register is one we are using, and as well as the displacement value. Here it is the displacement value along with the base register. So by adding these two, we access the data in a segment of the memory. Now this can be computed like this. The data segment you have to take a 2000h. Here the data segment let us take a 2000. So that it is a 20,000h, because we just multiplied with 2000h into 10h, 20,000h. Then here the bx value, let us take this is 200h value, and 200 plus offset value we provided, our displacement value or offset value provided as a 10h direct fixed value. So 2000h plus 10h is a 210h. This 210h connected with base value, so that it is a 20,210h value. This 20,210h value may be reside at the 8086 microprocessor somewhere here. This has some value like 34 and 12h. So this value will be loaded into CX register. This 34 is CH and 12 is lower byte H. So like that you can compute register relative addressing mode. In the previous classes we have seen the direct displacement value to compute the particular memory location. After that, in place of the displacement, we have seen the register as a displacement value or offset value. After that, we have used register plus displacement value. That is the register we are using base register as a base, and in terms of the displacement we can use the DI register. So base plus index register, and base relative addressing mode, base plus direct offset value we are using. That is the different types of addressing modes are there to access the particular memory location and to move one register to another register. And so like that we can manipulate, we can use different types of addressing modes. And let us take another example. Move cx comma bx plus 5h. How can we do that? Bx is a 200h and this is a 5h. So 200 plus 5, 200 plus 5. This is a 200h and this is a 5h. So it is a 205h. After that, the same value we can assume 2000h into 10h. 20,000h is the segment base value. So 20,000 plus 205, 20,205. So this 205 may be somewhere like this. The data will be loaded into CX register. So similar manner you can understand the register relative addressing mode. That's it. Now we have another doubt: how to addressing array data with register relative. So simple. Suppose let them take an example. Move cx comma array DI. If you write like this, when the term comes array, automatically the bx register will takes into the picture. So the bx register is considered as array here. Let us take 200h. And the default segment data segment is a 2000h. So it's a 2000 means the 20,000h memory location, and this 20,000 and 200h will be added. 20,200h. After that, this 20,200h added with the particular data element of DI. This DI is some value, maybe it's 5. So 20,200 plus DI, 20,000 plus 200 is equals to 20,205. This is the element we have to access in a 8086 microprocessor. So that will be loaded into the CX register after executing that instruction. So the array starts at somewhere here, and this DI will helps to find the particular element in that memory location. So by calculating the value, some array 0, array 1, array 2, array 3, array 4, array 5, somewhere around at this particular memory location, we can access the data. So addressing array data with a register relative can be computed like this.